Hey, what's up, everybody? Welcome back to another episode of Hacking Smart Contracts for Fun and Profit. So, today we're looking at challenge number 9, Puppet V2 from Damn Vulnerable Defi. So, the developers of the last lending pool are saying that they've learned their lesson and just released a new version. Now they're using a Uniswap v2 exchange as a price oracle, along with the recommended utility libraries. That should be enough. You start with 20 ETH and 10,000 DVT tokens in balance. The new lending pool has 1,000,000 DVT tokens in balance. You know what to do. Okay, let's check out the contracts. Okay, so we have the Puppet v2 pool contract here. So at the top, we can see they're importing this Uniswap v2 library and SafeMath. They're using an interface for an IERC20, and then they're importing a couple functions: transfer from, balance of. And then down here, we get into the contract. So we have a reference here, a pointer to the Uniswap pair, the Uniswap factory, and then we have an instance, an IRC20 instance of the token and also of the WETH. And next we have a mapping called deposits that takes an address and maps it to a uint. And lastly, we have an event called borrow that just emits an event when we borrow something from the pool. Okay, so in our constructor, we are just taking some of these things from above and we're just initializing them down here. Okay, pretty straightforward stuff. We can read this little notice here about the borrowing. So allows borrowing amount of tokens by first depositing 3 times their value in WETH. Sender must have approved enough WETH in advance. Calculations assume that WETH and borrowed tokens have same amount of decimals. Okay. So our first function down here is called borrow. We have a check here that checks if the token dot balance of the balance of the token balance of this address is greater than or equal to the borrow amount. If not, we will get an error that says not enough token balance. Next, we have a variable called deposit of WETH required is equal to calculate deposit of WETH required, and we take in the borrow amount. So let's find, this is a helper function to help us figure out how much collateral we're going to need. So let's just find this function down here, which is right here. So this takes in the token amount, and then we return get oracle quote with the token amount. So we have another helper function right here. Let's find this and figure out how this is getting calculated before we get into the rest of the calculations here. So it's right below. It's just called get oracle quote. And we can see here we're using a couple variables, reserve WETH, reserve token. That is going to be equal to this function right here. This is from the v2 library, and it's using a function called get reserves, and then it's feeding some inputs here from above. It's feeding in the Uniswap factory, the WETH address, and the token address. So this is just going to take our inputs and figure out what we have in reserve for these tokens. After it figures that out, it's going to pass it into another function from the v2 library called quote. So quote is going to take in the amount, do this multiplication on it, and then it's also going to take in the reserve tokens and the reserve WEF. So in order to dig into this and find out exactly what's happening here, we're going to have to look at the Uniswap GitHub page, which I have pulled up right here. So I highly recommend you checking out this Uniswap GitHub page. It has a lot of interesting, useful things on here. So this is the library I have pulled up here. It's just called Uniswap v2 library. And then we have all the functions available that we are importing from. So here we just have the quote function right here. So what is this doing here? It's taking in a couple inputs, and then we have a check here that requires the amount A to be greater than 0. If not, it's going to throw this error, and then we require reserve A to be greater than 0 and reserve B to be greater than 0. And then if not, it's going to throw us this error right here. And then finally, it's going to do this calculation. Amount B is equal to amount A multiplied by reserve B divided by reserve A. So basically, if we just kind of look up here, it's going to be this number multiplied by this number divided by this number. Okay, so let's just keep that in mind and go back to our contract. Okay, so let's just ignore this multiplication right here. These are, I think, if you're watching this tutorial, you probably understand what is going on here. This is just how Solidity works with floating point numbers. As I've mentioned in the past, Solidity doesn't work with floating point numbers, so this is the way we work with decimal places. Here it's adding some decimal places, and here it's subtracting some decimal places. This is pretty standard stuff. If you've gotten this far, I'm sure you understand this. So if we just kind of forget about this multiplication part right now, just to simplify things, we can take an amount here. Let's just say the amount we want to borrow is 100. We want to borrow 100 tokens for simplicity's sake. We'll input 100 here into the amount, and then the reserves. In the reserves, we can find, so here if we just pull up our test contract, it shows us up here. The exchange will start with 100 tokens and 10 WEF in liquidity. Okay, so right here we can say this is 100. We want to borrow 100 tokens. We put it in here, and then we multiply that by 10 WEF. That's going to give us 1,000, and then we divide it by 100 tokens, which is going to give us 10. So we can just take this, say that equals 10, place that in here, and that would be 10 multiplied by 3. And then once again, we're just going to ignore this part right here because it's just the decimals basically. So 10 multiplied by 3 is going to be 30. So if we want to borrow 100 tokens, that is going to cost us 30 WEF of collateral, which makes sense because 100 tokens is equal to 10 WEF. So to borrow 100 tokens, we need 3 times the amount of WEF, which is going to be 10 times 3, 30, right? So I hope you followed that. This is pretty much exactly like the last challenge, except the calculations are a little bit different, but it's exactly the same. We're still dealing with price manipulation, and we're dealing with price manipulation here. And this is, if you haven't seen my last video, I highly recommend you go back and watch that video first. And this is going to make a lot more sense because I'm not going to go as deep into the whole thing, but it's exactly the same. We're just dealing with the V2 Uniswap contract instead of the V1 contract. So a couple things are different, but the whole theory and everything behind it is exactly the same. And the attack vector is going to be the exact same. What we're going to do is we're going to devalue the tokens, and then we're going to borrow against those devalued tokens. So yeah, if you haven't seen it, go back, watch the last video. I'll put a link to it above somewhere here. And yeah, you're going to get a lot more out of this video. So now that we know how the calculation is done for the deposit and the collateral, we can go on to the next part, which is here. So we just take the WETH, this contract takes the WETH from us, and it deposits it as collateral. Then we do some internal accounting right here. This is the mapping we saw from above. And then we transfer out the tokens to the message sender for the requested borrow amount. And then we just emit the borrow event here, lastly. Okay, so that is the whole contract. And yeah, like I said, we're going to go and do pretty much the exact same thing as we did last time. And yeah, it's going to be a whole lot of fun. So let's just get into it. So I copied a couple things here already just to get me going. Just the IERC20 and the address. I don't actually need that part. I'll just go with the IRC20. So we will need an interface for the WETH. And all we just need a function. We're going to say iWETH is an IERC20 because it is. And we're just going to add a function on here. If you look at the WETH contract, there's just couple extra added functions on there, but it's inheriting from ERC20 ERC20 token. So we will just need an added function called deposit. It doesn't take any inputs. It's external and payable. And that's it. Oh, sorry. Yeah, so that is it. Next, we will need, an interface for the pool. We'll just call it iPool. We will need this borrow function. Copy that. Okay, and we will also need this calculation function here. Okay. And change that to external. Okay, so that's good for that. And finally, we will need an interface for Uniswap. And we'll just call it iUniswap. And for this, we're going to go back to the Uniswap docs page. And instead of the V1, I'm on the V2. And down here, if you look, I'm in the router number 2. And this function, it has all the functions over here. You can just kind of click through and find the ones you want. Has a lot of information, explains everything very clearly. Very good docs page. Good job, Uniswap. So here our function is called swap exact tokens for tokens supporting fee on transfer tokens. Okay, bit of a mouthful. So we will copy that. Just paste that in there. Okay, so that is it for our interfaces. Next, we will just get into the contract. We called this Puppet V2 attack. Scroll down a little bit. Okay, so we're going to need to set up a couple references and some variables. Yeah, so we're just going to set up an IRC20 reference, an called token. We're going to set up the iWETH. We'll call it WETH. We'll set up iPool. Call this pool. iUniswap. Call it Uniswap. And lastly, we will need a reference to our attacker EOA. Okay, so we will set up our constructor. So I will start just inputting all this stuff from above, pretty much. We input a token, the I, weth, pool, Uniswap, and the attacker EOA. Okay, now that we got those inputs set up, we need to initialize them like so. So token equals token. Oops. Weth pools equal to pool Uniswap underscore Uniswap, and attackers equal to attacker EOA. Okay, we've initialized all of those, and next we will just set up our attack function. We'll call it attack. We don't need any inputs. We want to make it external and payable. Okay, so scroll down a little bit, give us some room. So let's just list out the steps we're going to need. I always like doing this just to give me an idea of where I'm heading and what are the steps I need to achieve to accomplish this attack. So first, we need to transfer tokens to attack contract from our attacker EOA. Next, we will need to approve those tokens for Uniswap. Next, we will trade those tokens into pool to offset pool dynamic. Yep. So we will trade those tokens into the pool. Now the pool should have devalued the tokens at this point because we've traded tokens into it, offsetting the balance or offsetting the pool dynamic. Then we will need to wrap our ETH into weth. Wrap and approve. Wrap and approve our weth. Our ETH into weth. Yep, okay. That makes sense. Then we will borrow tokens. Yeah. Then, so we should have borrowed the majority of the pool. There'll be a little bit of leftover tokens in the pool, but we can just transfer some weth into there to collect the rest of the tokens. So we will need to approve our weth for Uniswap to spend, and then trade leftover weth for tokens. And at this point, we should have all of our tokens into our attack contract. And last thing we want to do is transfer tokens to the attacker EOA. Okay, that should be it. Let's start coding. Okay, so we go token, we'll transfer from. We want to transfer from the attacker EOA to address this. and we want to transfer whatever balance the attacker has in our attacker EOA. Okay, so next we will approve the tokens. We will approve Uniswap so that it can spend our tokens, and we will just approve it for the max. We will just go max. There's a lot of reasons why you probably don't want to do that, but I'm just going to be crazy right now, and we'll get into that on later videos. But just easy math. I don't have to think about exactly what I'm approving it for. I just go max, like pedal to the metal here. Next, we want to trade our tokens here. So before we trade, we need to make a path for these tokens. So that's one thing that's different here in this Uniswap v2. It has an input for a path, and it's looking for an address array. So basically that's just a path from one address to, like, one token address to another token address, and that's what it will trade from. So we just need to set that up like so. Let's say address, memory, we'll call this path equal to new address array, and we'll give it a length of 2. And then we'll say the first address in the path is going to be equal to token, and then the second address in the path is going to be equal to WETH. So this is the path is we're gonna trade our tokens for WETH. Okay. So next we will just call the swap function. The amount in is going to be the token dot balance of this. Let me just break these down onto different lines here. Okay, so the amount out, we want at least 0 tokens. I mean, we can put 0, we can put 1. We want at least 1 token in here. The path is called path. Address 2, we want to send it to this address, and our deadline, we're going to go block dot timestamp plus 500 seconds. Okay, so now that should trade tokens into the pool, and it will return us some WETH, and we would have massively devalued our DVT tokens. So at this point, we want to wrap our WETH to use for collateral. So we will just say WETH.deposit, and we need to attach a value to it. Value, and the value will just be address, this, balance. Okay. Yep. And we will approve the pool. We need to approve the pool so it can withdraw the WETH from our wallet and use it for collateral. And we will just approve it for max. Okay. So next we want to just borrow the tokens. We'll get the balance of the pool. We'll call this pool bal. Okay, so this will give us, oops. Okay, this will give us the balance of the pool, and then we just call borrow, and we say we want the, oops, We want the whole balance. And this will automatically withdraw the WETH from our wallet. So we don't need to attach anything, any value or anything to this function. Okay, so at this point, we should have withdrawn pretty much all of the tokens from the pool. There'll be a small amount remaining in the pool, so we will just trade some WETH for those remaining tokens. But first, we need to approve our WETH for Uniswap, because above we approved it for the pool, but we also need to approve Uniswap to spend our WETH. And we will just go we'll just approve it for the max. And then once again, we need to make a path for Uniswap to trade through. So we will just copy this from above. We'll do the exact same thing here. We'll call this path 2, but we need to just swap this. We need to make it the reverse of what we were doing before. We also need to call this path 2 and call that path 2. Yeah, so this is the new path to use. We'll just set up call our swap function again. The amount in, we will just say WETH dot balance of address this. Let me just break this into different lines here. Okay. Of so amount out, we want at least one. This is called path 2. We're going to be sending it. We want it to send to our address, and the deadline is going to be like, let's say plus 500 seconds. Okay, so now we should have all of the tokens in our attack contract. The last thing we want to do is transfer them into our attacker EOA. Okay, so that should be good. Okay, I think that's good for our attack contract. Okay, let's set up our test. Here we go. So we'll say this dot hack equal to await factory. We called this puppet v2 attack. We need to make the transaction from attacker. We will chain a deploy function onto this, and then we need to deploy it with the proper inputs as we set up in our constructor here. So token, WETH, pool, Uniswap, attacker. Okay. So address this dot lending pool dot address this dot Uniswap. We're dealing with the Uniswap router today. Dot address and the attacker dot address. Okay. Should be good. Next, we will need to approve attack contract to spend tokens, because we want to transfer our tokens out of our attacker EOA into the attack contract, and then we'll do our black magic voodoo, and then we'll transfer them back to our attacker EOA at the end. So we just say this token. We need to connect the attacker wallet. And then we need to approve this hack.address. We'll approve it for attacker initial token balance. Cool. And the last thing we want to do is just call, I'll just put some awaits in front of that. Last thing we want to do is just call this hack attack. And we will also need to attach a value. We will want to send our ETH along with this transaction because the attack contract is going to want to be spending our ETH as well. So we just say value, we say ethers dot utils dot parse ETH. And for this one, we start out up here. The attack contract, the attacker EOA, it starts out with 20 ETH. So we will just send 19.8 and we will keep just a little bit for gas. Okay, so I think that is good. I save it and save this. Okay, let's try it out. All right, moment of truth. Okay, compiling, good, successful. Oh, and we passed, first try, okay. Well, that is it for Puppet V2 Challenge. I hope you've enhanced your knowledge on price manipulation and you've learned something about the V2 and router. And we will check you on the next one.